So let's see, guys, what's the agenda for us for today. So I'll be giving a quick overview on the supervised learning in Mahout. One is supervised learning. To define supervised learning in short, so training the system with examples is called as supervised learning, or else training the algorithm with a teacher also can be treated as the supervised learning, guys. So you first train the algorithm with all the sample data, with all the labeled data, which has both the predictors and the target variable, and you train the algorithm, and then you use the unseen examples for further classification. Don't worry, I have used too much of terms over here. If somebody is not unclear about some of these terms, don't worry, we'll be looking at those things in a while. So for example, the correct results targets are known and are given in input to the model during the learning process. The construction of proper training, validation, and test set is crucial. And these methods are very fast and accurate. So supervised learning specific methods are very fast and accurate, and it depends upon, accuracy purely depends upon the amount of data you use as part of the training, folks, and how to be able to generalize, give the good results when new data are given in the input without knowing the priority to the target. So let's see with an example. Let's try to understand supervised learning with an example which makes more sense to us. So guys, so this is a high-level flow of a supervised learning model. So before we actually discuss about this entire flow, let me show you one slide over here quickly. Say, for instance, if you have created if you want to train the machine in such a way, okay, let's take a simple example over here. For instance, if you are given with corpus of images, one with say elephant images and the other corpus of images with say lion, okay, along with the labeled data. When I say labeled data, each data set along with its target value. For instance, if I consider this one of the images over here, what is the target value for this, which is none other than elephant. And if I consider one of this image over here, the target value is actually lion over here. So since all these images comes along with these labels, that's why I'm calling this data set as the labeled data set, and I use this labeled data set as part of the training process so that the training algorithm will actually leverage on this data set and will build some model, and that model will be further used to classify the unseen examples without the labeled data, without the target variable, folks. So guys, if I take, let me just quickly take a notepad over here. Okay. Guys, can you please tell me what sort of features will help to actually identify a specific image as the elephant or specific image as the lion? Can you please tell me what sort of features? Otherwise, instead of images, let's call it as, what sort of features will actually help you to identify a specific object to be an elephant or say lion, or the chart window, guys. Okay, so Apurva has some answer over here. So Apurva says it's shape, okay, size, okay, color, and then height. Excellent. Then say, okay, ear size, and can I use trunk? Trunk also one of the features, right? So okay, so maybe okay. So let's restrict ourselves to only these things. I think there are some other tasks. Okay, so John says it's tasks body size. Okay, so let's test tasks also. Okay, so guys, if you consider these are the different features, and we can actually call this feature set, I mean this entire feature set will be used while training the example, and since these feature set actually signify the final, will actually impact the final target variable, these variables can be treated as predictor variables, because these variables help us to determine the final target variable. So that's why we are actually calling all these features as predictor variables, and the final variable we can also call it as the label as well. And here the final variable is either elephant or lion. So these are the final outcomes, right? So this is the label. So let's now just take sample records over here. So for size, shape, okay, instead of shape, let's take size itself. So and else shape also, I think. Okay, so don't worry. So size, if the size of a record, say for example, if I have a specific training example, so I'll just call it as example 1 or whatever. So size is say somewhere around 400. Color is say some color over here. So let's call it as black, and say height as some 700. Ear size as some around 200. Say trunk as say S, and say tusks as S. And let's take another example. Okay. So another example, say with some around 500, and say some, okay, not 500, probably let's call it as 100, and say brown or whatever, white, brown, any other color, and let's have some height as say again 150 or whatever, and say 150 again. So again, no. Okay, so this has a label as, for instance, elephant, and this has a label of say lion. So now that we understood what is a predictor variable and the target variable, so let's try to understand other terminology also here. So these records which has both the predictor variables and the target variable, I'll actually treat these records as the training examples, training data set. This entire corpus I can treat it as the training set, and each one of this I can call it as training example over here, folks. Okay, so considering such a situation, so if supervised learning is a way through which you train along with the labels. So since we already have the labels here, I'm just calling this as the supervised learning, and you ask the algorithm to extract certain features out of it, and based on that, next time when you pass an unseen variable or unseen example, then the algorithm will be able to classify it into the right class, guys. So that's whole flow has been represented in this slide over here. For instance, if you are given with the training text, which is the documents or images, etc. So if your training set contains say images, for instance, then you actually use this training data set along with the, so first you extract the feature vector out of your training set. So that's the first step. So since this is the raw data and you cannot straight away use this raw data as part of training the algorithm, the first step would be to extract the features, so which we have already done over here. And after extracting the right feature set, so which is this, extracting all these features, then you pass all these features, I mean these feature vectors, to the machine learning algorithm. So once you pass all these feature set to the learning algorithm, then the learning algorithm will actually generate a model. Model also can be treated as a simple program as well. Model is nothing but a program, guys. But in in machine learning we actually call that program as the model. So then this since this is a training data set, and since it's a supervised learning, the training data set also has the labels over here while actually training the machine learning algorithm. Okay, then after generating the model by training it with both training data and the labels, here we use the model to actually further classify the unseen data sets. Like the unseen image we actually pass and we extract the feature vector and we pass that feature vector to the model. Then let the model decide which label, which class this specific vector will belong to. So it will actually simulate the expected label over here. So this is how supervised learning model works. Even if you don't get some of bits and pieces over here, don't worry, because we'll be having dedicated sessions for classification. Then that's where we actually understood in detail about supervised learning, folks, and all these terminologies we'll be continuously using this. So we'll get once we get to that level.